Hello everyone, welcome. I'm the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. The subject is computer networks, and the topic is about wireless sensor networks, challenges and opportunities. Wireless sensor networks have an emerged as a transformative technology which enables the wide range of applications from the environmental monitoring to the smart cities. Let's go with the introduction first. Network management is the process of managing, monitoring, and controlling the behavior of a network. Wireless sensor networks poses the unique challenges for network management that make the traditional network management techniques impractical. The traditional networks that primary goals are minimizing response time and providing the comprehensive information, but in sensor networks, the primary goal is minimizing the energy use one, and the main means of doing this is by reducing the amount of communication between the nodes. Monitoring the individual nodes in a large sensor network may be impractical, but it is sufficient to control the network by ensuring the specific network coverages. Sensor network management system should allow the network to self-forming, self-organize, and ideally to self-configure in the event of failures without the prior knowledge of a network topology. Sensor network applications are designed with the network management in mind, thus, no extra network management layer is required. Wireless sensor networks, disrupted sensing, resource constraints, and the applications. WNSN wireless sensor networks consist of numerous sensor nodes that connects the data from the other surroundings and the wirelessly transmit it to a central processing unit. Resource constraints, sensor nodes have limited power, memory, and the computational capabilities, posing the unique design challenges. Applications, WSNs find the applications in diverse areas such as environmental monitoring, healthcare, industrial automation, and the smart city infrastructure. Wireless sensor networks are emerging applications for the pervasive computing consisting of many small, low power, and the intelligent sensor nodes and one or more base stations. Sensor nodes gather the information in diverse settings, including the natural ecosystems, battlefields, and the man-made environments, and send it in the information to one or more base stations. Sensor nodes work under severe source constraints such as limited battery power, computing power, memory, wireless bandwidth, and the communication capability, while the base station has more computational energy and the communication resources. Management functionality. Traffic management functions are provided in SIFON, DSN RAM 27, and the WinMS 17. SIM Phone 26 uses the multi-radio nodes to redirect the traffic from the common nodes in a network in order to prevent the congestion at the central server and in the primary radio network. Congestion can also be avoided by modifying the sensor nodes and reporting the rate based on the reliability level of the sensor node data. By reducing the node's reporting rate and the number of packets transmitted in the network is reduced, so avoiding potential congestions. Chapter overview. The remainder of the chapter discusses different approaches to network management system organization. Section 3 identifies the criteria that must be satisfied by the network management system for sensor networks. Section 4 that reviews the state of the network management systems and for the sensor networks. Energy efficiency in the network management, energy aware routing, duty cycling, and the power management. Energy aware routing the protocols that consider the remaining battery life of a nodes when selecting the optimal data transmission paths. Duty cycling the techniques that allows the sensor nodes to alternate the different activate and sleep between the active and sleep modes to conserve energy. Power management algorithms that efficiently distribute and regulate the power consumption across the network. Network management in the wireless sensor networks, topology control, resource allocation, and the fault tolerance. Organizing the network structure to optimize the connectivity, energy efficiency, and the data routing. Topology control in network management refers to the techniques and protocols used in organize, manage, and to maintain the structure of the network. It is particularly important in wireless sensor networks, mobile and the networks and the mesh networks. Resource allocation efficiently managing limited resources like bandwidth, memory, and the power to ensure the reliable and the scalable network operations. The process of distributing the available network resources such as bandwidth, power, spectrum storage, and the computational capacity among the different devices, users, and the applications effectively to ensure the optimal network performances. Fault tolerance, designing the mechanisms to detect the and diagnose the recover from network failures and node malfunctions, and the ability of a network to continue functioning the properly even when the sum of its components such as routers, switches, servers, or links fail. A fault tolerant network is designed to minimize the impact of hardware, software, or communication failures by automatically detecting and recovering from faults without significant of the service disruption. Routing protocols for wireless sensor networks, data centric routing, hierarchical routing, location based routing, and the mobility aware routing. Data centric routing protocols that focus on the data itself rather than specific node addresses, enabling the efficient information dimensions. Hierarchical routing protocols that organize the node into clusters with the cluster heads responsible for the coordinating data aggregations and transmissions. Location based routing protocols that uses the node location information to make informed routing decisions and to minimize the energy consumption. Ability mobility aware routing protocols that adapt to the dynamic movement of nodes, which ensures the reliability of the data delivery. Network management systems design criteria, lightweight operations, robustness and the fault tolerance, adaptability and the responsiveness, minimal data storage and the scalability. Lightweight operations, a system should be able to run out sensor nodes with consuming the too much energy or interfering with the operation of a sensor nodes. Lightweight operation prelocks the network lifetime. Robustness and the fault tolerance. Wireless sensor networks are prone to network dynamics such as dropped packets, nodes dying and becoming disconnected, powering on and off, or nodes new nodes joining the network. A management system should be resilient to the network dynamics by reconfiguring the network as required. Adaptability and the responsiveness, a system that should be able to retrieve and adapt the data that the current network status are the changing the network conditions that includes the changes in a network topology, node energy level, and the coverage and explore bounds of ones. Data aggregation and the dissemination, data collection, data aggregation, data dissemination. Network monitoring tools function. It functions the monitor of the network performances, availability, and the real health time. They track key performances indicators like the bandwidth, usage, latency, packet loss, and the server uptime. which enables the administrators to quickly identify and resolve issue before they affect users. For examples, solar wind network performances monitors, Nagosis, and Zibex. Security considerations in the wireless sensor networks. Authentications, confidentiality, resilience to attacks. Verifying the identity of sensors nodes and ensuring the data is transmitted by the legitimate sources. Confidability that protects the sensitive information from unauthorized access through the encryption and secures the communication channels. Resilience of the to attacks, designing mechanisms to detect, mitigate, and recover from the cybersecurity threats and the attacks. Deployment and the scalability issues. It involves managing a diverse range of sensor types and the capabilities within a single network. It adopts the changing in a network structure due to the node failures, mobility, or addition of new devices. It enables the decentralized decision making and coordination among the sensor networks for the scalability and the operations. Stimulation and the experimental evaluation. Stimulation platforms, test beds, and the performances evolution. Specialized tools like NS3, OMNet++, and the Castelia enables the researchers to model and analyze the wireless sensor network behaviors, test beds the real-time board deployments, and the experimental setups, which helps in validate to theoretical findings and the assess of the practical changes. Performances evolution that matters is like latency, reliability, and the energy consumption, and the scalability are used to assess the effectiveness of a network system, wireless network system solutions. Here, the conclusion and the future directions. Wireless sensor networks continue to evolve, offering the uninterrupted opportunities for transformative applications as the field advances. Key research challenges and remain in areas such as energy efficiency, security, and the scalability. And the future holds the expecting developments in the rapidly advancing domain. Thank you.